Hello everyone! Last week I published my first talk at the Symposium about developer experience, and today I want to share with you the second one, solid CRDTs in practice. In case someone doesn't know who I am, my name is Noel and I'm a developer and entrepreneur. I'm currently working 4 days a week at Moodle and I am making solid apps on the side. I work in the open, so everything you see here today is open source, and you can learn more about me and my work in my website. The first Solid application I made was Solid Focus, a simple task manager, and this was actually my first encounter with Solid and RDF overall. So the solution I came up with was simply to create requests every time you did anything in the application over the Solid pod. However, the UX wasn't great. Once you had a lot of data, every time you reloaded the application, you had to wait for all the fetch to complete to get all the data from the pod, and this was quite slow. So for my next application called Media Kraken, which is a media tracker, it was my first attempt at caching some pod data locally. The UX improved a lot, but it still wasn't great because you still have to wait until it synchronizes the first time you open it. And also, depending on some specifics of the pod implementation, it's also very slow. You can check more about that specifics in this issue in GitHub if you want. So finally, for my latest application called Umai, which is a recipes manager, I finally implemented a real local first approach, which gave it a good reloading experience. And all of this happens thanks to CRDTs, which is what I'm going to talk about today. In case you don't know what a CRDT is, basically it's a conflict-free replicated data type. An easy way to understand it is like Git, but without merge conflicts. If you want to learn more about CRDTs, I suggest that you start in this essay by InCanSwitch, where they explain the basic motivations and ideals of local first software. Also, if you want to see an example of some of the practical implications for implementing it, I suggest that you check out this talk by James Long, where he goes about it in some practical details. And if you start getting to CRDTs and you want to learn more, you will eventually find something like this, because one of the most common examples for CRDTs is solving real-time text editing. However, when I started learning about this, I thought this was a bit complicated for my use case. After all, I was just trying to implement a recipes manager. So having learned about CRDTs and how this is solved in other scenarios, I went back to the drawing board to see how I could solve this for Solid. And I had some design constraints. The first one is that I wanted it to work with any spec compliant Solid pod. After all, the promise of Solid is that if someone has a Solid pod, they can use my app. So I didn't want to rely in any experimental features or something that only work in some pods. Also, I didn't want to have any server-side dependencies. As I mentioned, I am working as side projects and all my applications work in the front end. So I don't want to have any hosting or server-side dependencies. Finally, I want it to be interoperable with other applications. I think that interoperability is one of the most important things in Solid. So even if the CRDT thing doesn't work, I think the recipes themselves should work with other recipe managers. So these are the basic constraints I had when thinking of my solution. And what I came up with is basically to treat RDF triples as the atomic unit in the CRDT data type. So the way CRDTs work is that everything that happens is encoded in an operation. And these operations are replied from the beginning to recreate the current state of the app. So in our case, we can do everything in RDF just having these two operations, a set property and an unset property, which would create or remove an RDF triple. However, I also created a couple more that could be useful to improve this. For example, we have one to add property of remove property that instead of setting or unsetting a specific triple, they can set or add or remove triples from a specific property. For example, in a recipes manager, if we have an ingredient triple that can have many ingredients, you can use these operations to set many at once or remove at once, instead of having to create one operation for each ingredient. And finally, if you want to delete a resource, you can use the delete operation, which would delete the entire resource instead of having to remove all the properties individually. If you want to learn more about this vocabulary and see some of the specifics, you can check it out online here. So this can seem a bit abstract, talking like that, so I decided it's better if we go through a specific example. In this case, this is a screenshot of my application, Umai, where we have a ramen recipe. And this is the initial state we are going to go through. We have a mobile device with our data, we also have the data in a desktop device, and we have the data safely stored in a solid pod. Imagine that you start editing the name in your mobile device, but it's not connected to the internet. So for now the changes stay locally in the mobile device. Later on you go to your desktop device and you change the description, and this time, because you are connected to the internet, the changes are synchronized with the solid pod. However, later on, when you finally get internet access in your mobile device, you will have some problem, because you will see that something has changed both locally and remotely, but you won't be able to know what are the differences. So it will not be possible to resolve the changes like this. And this is what CRDTs want to solve. So let's go back to the beginning, and this time we are going to do the same thing using CRDTs. So the first time something changes is the name in the mobile device, and this time, besides changing the data of the recipe, we also create a new operation, in this case an operation that would update the name property. Later on in your desktop device you do the same, and when you synchronize the data with the pod, you also push the operations, not just the changes to the recipe. That way, when the data is pulled from the mobile device, we would get the new operations and we can reconstruct everything from scratch, and thus we would have the latest state of the application without any conflicts. When we synchronize with the pod, we also send our operations that we had locally, and this way when the desktop receives the new operations and reconstructs the state, because it has all the same operations as the mobile, the final state will be the same. And this is the basic idea of how CRDTs work. Let's take a look at the exact RDF that is generated in this situation. First of all, as I mentioned, the recipe itself should be interoperable with other applications, so it's using the schema.org ontology. Then we have some metadata using the CRDT ontology for the synchronization. Here we have some of the operations. In this case, these are the operations that were created when the recipe was created the first time. This is important to keep in mind. You also need the data from the initial state, not just the state created when you edit the data. And here we have an example of the operations we created in our example of modifying the name and the description. So when you look at all of this, you may be thinking that this is not so simple after all. I was complaining about the real-time text editing, but now I have created a bunch of data, right? Well, I would say two things about that. First is that this is quite easy to understand. As I mentioned, we are only using some basic operations that create or delete triples. So conceptually, I think it's very easy. And second, in terms of implementation, this is not something that you all have to keep in mind all the time when you are working on your application. Since it's working on RDF triples, there is no specific business logic, and this can be reused in all the applications. In particular, for my use case, I am using something called active record, which is a design pattern. In this design pattern, you create an object that wraps a row in a database table or view, encapsulates the database access, and adds domain logic on that data. In our case, I would say that it wraps an RDF resource and it encapsulates the network requests. So for example, using this design pattern, since my first application, I could do this. When the data is created, I could decide if I wanted it to store it in a browser storage or in the solid pod. And later on, when I decided to start following this local first approach, I could just store everything in the local storage and synchronize to the pod in the background. That way the application works local first, and you don't have to change your code to handle this scenario. And this is something that, thanks to the active record design pattern, I could implement in my applications without changing any of the business logic or the code for the application themselves. So this is an example of how you would implement this thing we saw in the examples of updating the name and the description, and as you can see, you are not specifying any CRDTs or anything. The operations are created under the hood. If you want to learn more about this and how I implemented it, it's actually using this library called showkaijs.org, which I created. And I'm also working on a framework called Aerogel to create local first applications. And if you are interested to learn more about both of these, this is what the talk I uploaded last week about developer experience is about. So I just suggest that you check it out if you want to learn more. So yeah, basically that's it, but before finishing, there are some known issues and improvements I am aware of and I would like to discuss. First, I am using a custom ontology for the CRDTs. So even if the recipes are very likely to be interoperable, the CRDT part are not for now. Also, there is some data duplication. The operations have some data about the recipe, but also we have it in the schema.org ontology. So there is no single source of truth, and ideally we would have only one. Also, there is some data overhead, and this may not be an issue, but it could also be improved with some more specific operations or some different modeling. This is something I didn't talk about, but when you are using distributed systems, it's usually a bad idea to rely on the clock of each machine, because then they may not be synchronized completely. For my use case, I didn't care too much because I am only doing a recipes manager, so it's not critical that it works perfectly like that. But if we are going to use this kind of approach for more data intensive operations, we should probably keep that in mind and use logical clocks. Finally, my application is not actually real-time because it's doing the synchronization every some intervals or when you refresh the application, but using something that like solid notifications, we could actually make it real-time. When some operation is created in the pod, we could be notified and update our application. And yeah, basically that's it. I hope you find it useful and interesting, and as always, you can ask me any questions and I'm looking forward for your feedback. Thank you.